Hello class, welcome to section 15.2. This continues with our measures of central tendency, things like mean, median, mode. So let's go over our definitions first. As I said, measures of central tendency include values like mode, median, mean. There's statistical values, obviously, that describe how data is distributed. Mode, some of you may remember from if you had this type of class before, is the number that occurs the most in a set of data. And there could be multiple types. You could have no mode, mean that every value occurs exactly once. Or you could have multiple modes, or bimodal for two specifically. So you could have 2 or 3 data values that are tied for the most frequently occurring. The median is the middle number of the set when you organize from least to greatest. And as we'll see, there are 2 ways of finding that. Mean is probably the one everyone's most familiar with. It's another way of saying average. We add up all the numbers and divide by the total number of values in the set. And the mid-range you get by adding the lowest and the highest value and then dividing by 2, of course. And finally, the 5-number summary. This is often used to give kind of a basic overview of data description. It's also used to make a box plot. 5 values that again give a particular overall description of the data set. So we have the minimum value, the first quartile, second quartile, which is also the median of the overall set, the third quartile, and then the maximum. So let's take a look at some examples. Again, we have a mean represented by this figure. If you're not familiar with the Greek lettering, the X with the bar over it is another shorthand representation for mean. The little E looking figure there is called sigma. What that means in math is that you add up everything that's after. So in other words, any value of X, you add them all up and divide by n, the number of elements in the set. Also called summation notation. So a common example would be find the mean from a frequency distribution. So scores are 3 through 7 and the frequency which with they occur. So to find the mean, so we need to add up all the possible value sets. And since we have a frequency distribution, the score of 3 occurs with a frequency of 2, so it goes for a total of 6, 3 times 2. A score of 4 goes with a frequency of 6, so 4 times 6 gives us 24. A 5 happens 9 times, so 9 times 5 is 45. 6 happened once. And of course 7 happened 10 times, which would then be the mode, for a total of 70. And we add these all up, we get 151. Divided by the total number of elements, which is 28. And our mean is 151 over 28. Which you could reduce or give me as a decimal value as well. Now onto the median. Again, order from least to greatest. It's the number in the middle. And like I said, there's 2 types. If it's an odd number of items, the exact middle number is the median. If it's an even number of items, the median is the average of the 2 middle data values. And let's look at an example. So here's our data set. First thing I recommend whenever you're finding median, and in particular like a 5-number summary also, is to put it in order from least to greatest. Now there's an odd number here. There's an odd number of values. So, in order from least to greatest, and you see I've highlighted here. The middle value is 8, so that's our median. Again, because it has the same number of elements after it, 5. Same number of elements before it, which is also 5. So again, it's the exact middle. Another example. have these. So the first thing to do is order it from least to greatest. And when I do, I have an even number again. So you can see here I have 10 values versus 11 in the previous one. So you can see I've highlighted here exactly 5 on each side. So when I say the two middle values, the two are at the inner ends of those blue and red blocks. That's a 33 and 35. Those are considered my middle values. So to find the median of an even number set, like this, we take the average of those two values. 33 plus 35 divided by 2 gives me, in this case, 34. Now, not every data value set that you get will give you a whole number for a median in a case like this. Sometimes you'll get fractions. You'll get maybe 34.5 or 34.6. So that's not unusual, and it's not restricted to just integers. And here's a general rule. To find the position of the median, if data is arranged from least to greatest, you can find the position now of the median by this formula, where n is the number of elements in the set. So here's this data value set again. This is the first one. We had 11 values. So this means that when I follow my formula, n plus 1 over 2 gives me 12 over 2 or 6. So this means the sixth position holds the median. And if I count over 6 positions from the start, 1, 2, 3, 4, 5, 6, that's my 8, which we established earlier was indeed the median. So this is a little shortcut you can always use. It's not something that you're required to know, but it can help you just to verify median and help you kind of narrow down where to look. Just remember, we always want to put it in least to greatest order. And here's another example with even number. Same data set, this time with 10 values. So when I put it into my formula, I get 5.5. So that means the 5.5 fifth, I guess that'd be the way to say it, position, you'd say, okay, well, that's obviously halfway between the 5th and 6th term. So again, I find you just count down, 5th term is 33, 6th term is 35, so obviously it must be between them. Now onto the 5-number summary. So here's another set of values. Find the 5-number summary. First of all, the best thing to do is find the median of the overall set. So we're going to order from least to greatest. It's an odd number, so it turns out that 55 is my middle number. Now, one thing this helps us to figure out what the different quartiles are. So if you find quartiles, third, first, etc., you always want to find the median of the overall set first. That's actually the second quartile. So the median in general is actually always going to be referred to as the second quartile. So whenever you find 5 numbers, do the 5-number sum, you always do that first. Every number, every data value below that 55 is used to determine the first quartile. Notice I'm not including that. So I'm not including the 55 that was in the middle. I just want everything to its left. That's all these. And you can see I drew it down here. Since that's an even number, 8, the middle term, median, is the first quartile. So the median of this new data set is between 51 and 51, which is, of course, 51. That becomes our first quartile. Similarly for the third, if you look back up, everything above 55 is written here. Again, I have an even number. So my two middle values are 61 and 60. When I find the middle term, I get 60.5 as my median, which means 60.5 is the third quartile. Then you remember the other parts is the highest and lowest value. So the lowest value is 42, the highest value is 69. So this is our 5-number summary: 42, 51, 55, 60.5, and 69. Now, one of the other things the 5-number summary is used for is to create a box plot. Box plot is just a visual representation of the 5-number summary. You have two endpoints which are referred to as whiskers. Then you have the 3 quartiles in the middle, drawn as vertical lines that comprise a box, as such. On the bottom here, the very bottom, you see the long line, that's a number line. So between 50 and 60, again, the endpoints out here are the 42 and the 69, those are referred to as the whiskers. And I should say, to be completely accurate, we usually have a point out here. There we go. So again, this is a more accurate picture. We have whiskers at the very end. That's what those endpoints are called, the minimum and the maximum value. In the center, you see we have our 3 quartiles, 51, 55, and 60.5. Each of those is represented by a vertical line, which creates, as you can see when you connect the endpoints, a box. Again, this is a visual representation of the 5-number summary. This concludes section 15.2. As always, if you have any questions, feel free to contact me, and have a good day.